In this video, I am going to be talking about how you can decompose partial fractions with repeated linear factors. Taking a look at the example we have, looking at the denominator, we have x times x minus 1 raised to the power of 3, so which means that we have a product of x and x minus 1 multiplying itself 3 times. When we try to break that down, we have a divided by the first m, which is x, and the second term b over x minus 1 plus c over, now it is repeating, you have to put that into consideration. You're not going to write x minus 1 here again, so it's going to be x minus 1 all squared plus d over x minus 1 raised to the power of 3. So it keeps increasing that way. Now we take a common denominator here. So the common denominator from here is x minus 1 raised to the power of 3. Now this gives a times x minus 1 raised to the power of 3 plus b x times x minus 1 raised to the power of 2 plus c x then x minus 1 plus dx. All of this here must be equivalent to x squared plus 1. Now, when we try to expand this, we have a times x cubed minus 3x squared plus 3x minus 1 plus, and then the expansion of this gives x cubed minus 2x squared plus x plus c x squared minus x plus dx. So we are taking that with x squared plus 1. Now all we have to do at this point now is to try to match up what you have on the left hand side of the equation to that we have on the right hand side. So taking a look at each of the terms by their degree. So for degree 3, which is x cubed, we have a x cubed, and in the second parenthesis we have b x cubed as well, and on the right hand side there is no equivalent degree, so we can pick a zero coefficient x raised to the power of 3, and now we can say that a plus b equals 0. So there's a 0 here, so I can say that a plus b equals 0 for x cubed. For x raised to the power of 2, which is x squared, we have a negative 3ax squared. Here we have a negative 2bx squared, and here we have a cx squared. Now when you try to match that up with what you have on this side, you have an x squared here, which is 1. So I can write this as negative 3a negative 2b plus c equals 1. Equals 1. All right, that's better. Now we proceed to the next one, which is x. So that's going to give you 3ax and this bx and this negative cx, and this we have dx. Those are the x's we have on the left side, and on the right side again there is no matching term from that point of view, so we can just say this is a zero coefficient x, so which means this is going to be 3a plus b minus c plus d equals to 0. Lastly is the constant term, which is the negative 1 you have in the first parenthesis. In the second parenthesis there is none, in the third there is none, and in the fourth term there is no constant. So we have a negative a, and on this side we have a 1, which is the matching term 1. So we have a equals -1. All right. Now, if a equals -1, if you take that to the first equation, it means that b equals 1. And if you take that to the second equation, we have -3 times -1 minus 2 times 1 plus c equals 1. Okay, so this is 3 minus 2 plus c equals 1. So c equals 0. And now, sorry, I had to use the side. And now for d, we have a 3a plus b plus c, minus d plus d equals 0. So we have a -3 plus 1 plus 0 or minus 0 plus d equals 0. So d equals 2. Now, when you try to break this down now, we can break it down as -1 over x plus 1 over x minus 1 plus c is 0, so we're not writing anything, and d is 2, so we have 2 over x minus 1 raised to the power of 3. So this is the partial fraction decomposition of this. Now we have another question that says you should find the partial fraction decomposition of 7 minus 2x over x plus 1, then x minus 2 raised to the power of 2. Now, here we just have to split it up as a over x plus 1 plus b over x minus 2, and then repeating c over x minus 2 squared. Now we find a common denominator. For this, we have x plus 1, x minus 2 squared. So when you try to do that, we have a multiplying x minus 2 raised to the power of 2 plus b times x plus 1, x minus 2 plus c multiplied by x plus 1. Everything in the numerator must be equivalent to what you have at 7 minus 2x. So x plus 1 equals 7 minus 2x. So I'm going to use the cover-up method. If you don't understand the cover-up method, you can refer to the previous video. I am going to try to eliminate a and b by putting x to be equal to 2. When you do that, this goes to 0, this goes to 0, and we'll be left with just c. So we're going to have a 3c equals 7 minus 2 times 2. 3c equals 7 minus 4, which is 3, so c equals 1. Now I'm going to try to put x to be equal to -1. When I put x to be -1, I am eliminating b and I am eliminating c. So I have a times -1 minus 2 squared equals 7 minus 2 times -1. Okay, so this gives 9a equals 9. So a equals 1. So lastly, we need to find the value of b. So we cannot use the cover-up method directly at this point for calculating b, because when you substitute 2, it eliminates b, and when you substitute -1, it eliminates b as well. So what can we do in this case. Now, what we can do in this case is just, you can try to consider the x squared term. All right, the x squared term. That is, you can try to expand this by just taking that has to do with b alone. For instance, we have a times x squared minus 4x plus 4, okay? And for b, we have b x squared minus x minus 2, and for c, we have x plus 1. Now, when we take the x squared factor, we have a plus b, and on this side, which is the side we are comparing to, we have 7 minus 2x. Of course, there is no x squared term, so this is going to be plus 0x squared. So this is going to be equal to 0, and now that we know that a is 1, b will be equal to negative 1. And so we can try to decompose it as 1 over x plus 1 minus 1 over x minus 2. C is also 1 plus 1 over x minus 2 squared. Now the third case is when you have irreducible quadratic factors. So what does that mean? Take for instance, you have x squared plus 2 equals 0. This is going to be having a complex number as the root. That is, you're going to be having x equals to the plus or minus square root of negative 2. This is a complex number. Also, if you have x squared minus 2 equals 0, you're going to be having a real value, not complex, but this time it is going to be an irrational number. Now, coming back to the subtopic, irreducible quadratic factor. Now, you can say that your expression is irreducible if it has a complex factor or it has an irrational factor. Now, how do you break this down? You take a divided by x minus 3, right, plus bx. This is what you use, plus c for an irreducible quadratic factor, like this, okay, over x squared plus 4. So this goes as a times x squared plus 4 plus bx plus c multiplied by x minus 3. So we are taking this with x squared. So we have to expand here. A x squared plus 4a plus bx squared minus 3bx plus cx minus 3c. Then we have x squared on the right hand side. Now, what we have to do from here is to match up the degrees. So we have ax squared, we have bx squared. So we have a plus b. So which means we have a plus b equals, now there's an x squared here, which you can match up with the first x squared and the second x squared. So this is going to be equal to 1. Next, we can take all the x's, negative 3b and c. So we have negative 3b plus c equals, now if you check the side, there is no term we can call x squared, so we can just basically use 0. Okay, also we have the constant, which is 4a and negative 3c. So we have 4a minus 3c equals 0 as well. We can call this a first equation, this the second, and this the third. So how do you solve a problem like this? Now it is quite easy. All you have to do is just take the, I think this is a bit simple. equation 2, all right? From equation 2, we can see that negative 3b plus c equals 0, and then c equals 3b. Now I can place c equals 3b into equation 3. So I have 4a minus 9b, because you have a 3 here and then you have 3 then b, so 3 times 3 9, all right, so equals 0. Now we can match this up with equation 1, which is a plus b equals 1. So I can multiply this by 4. I have 4a plus 4b equals 4. So we have 4a minus 9b equals 0, and then 4a plus 4b equals 4. So when you subtract, you have negative 13b equals negative 4. So b equals 4 over 13. Alright. Now if b equals 4 over 13, obviously we can see that c is 3b. So if c is 3b, so it's just going to be 12 over 13. We just multiply this by 3. Lastly is a. Alright. A from here is a plus b equals 1. So we have a plus b equals 1, and a plus b is 4 over 13 equals 1. So we have a equals 1 minus 4 over 13. So a equals 9 over 13. A is 9 over 13, b is 4 over 13, and c is 12 over 13. So which means that this can be written as 9 over 13 times x minus 3 plus b is 4 over 13, right? So we have 4 over 13 x, right, plus c is 12 over 13, so 12 over 13 all divided by x squared plus 4. So this is the final answer, or you can rewrite this in a better way as 9 over 13 times x minus 3 plus 4x plus 12 divided by 13 times x squared plus 4. However, it is possible for you to have two irreducible quadratic factors in the same context. I'm not going to solve this comprehensively. I'm just going to give you the breakdown. Now, in this case, we have x squared plus x plus 2, which is irreducible. Then we have another x squared plus 1, which is also irreducible. So how do you break this down? You can break this down as ax plus b divided by x squared plus x plus 2 plus, then we have irreducible again, so we have cx plus d divided by x squared plus 1. So the last of all the 4 possible cases that we can have is the repeated irreducible quadratic factors, and in this case the process of decomposing an expression like this is quite similar to having a regular irreducible quadratic factor, only for the fact that this is repeating. So if we're going to break this down, we're going to have a x plus b divided by x squared plus 4 plus cx plus d over x squared plus 4 raised to the power of 2. So we're going to find a common denominator for this. which is going to be x squared plus 4 squared. And here we have a product of ax plus b and x squared plus 4. And for the other side, we have just cx plus d. And we'll try to break this down. We have ax multiplying x squared. You have ax cubed plus 4ax plus bx squared plus 4b. Now plus cx plus d all equal to 2x squared minus x plus 8. Again, match for match. We have ax cubed, no ax cubed on this side, which means a equals 0. So a equals 0. Now let's take the squares. Bx squared, we have 2x squared, so which means b equals 2. Now for the x, we have 4a, just this, and cx, so we have just c, and on this side we have a negative x, which is equal to -1. Now to make this easy, a equals 0, so this goes to 0, so c equals -1. And the last guy, which is the constant, is 4b plus d equals 8. Now b is 2, right? So we have 4 times 2 plus d equals 8. So ultimately d equals 0. Now the partial fraction decomposition of this, by substituting the value of a, b, c, and d, is going to be 2 over x squared plus 4. C is -1, so we have negative x. D is 0, so divided by x squared plus 4 raised to the power of 2.